Okay, let us discuss this problem. So this is related to concept of buffer. So this is something related to buffer. Easy problem we have this time. This is a small problem. So this says calculate the pH of a aqueous solution. This question is from T95. You can also write it here. So calculate the pH. So I have to find what is the pH of the solution. 1m ammonium format. Ammonium format is this NH4 plus, that is ammonium, and formic acid is HCOO minus. This is ammonium format. So concentration of ammonium format is given 1m. pKa for formic acid is another thing that is given. So pKa, and this is for formic acid, that is HCOOH. This is also given to you 3.8. And pKb for ammonia, that is given to you 4.8. So you have to calculate pH of solution assuming complete dissociation. So this means if you have NH4 plus HCOO minus, this basically initially concentration of this is 1m. So this dissociates completely. So you will have concentration of NH4 plus, that is 1m, and concentration of HCOO minus, that is also 1m. Now let us try to find out what will the pH of this solution. So let us think slightly. So this is a salt, that is NH4 plus HCOO minus. This is a salt of, so salt contains two things, NH4 plus and HCOO minus. Now see, this is a anion of weak acid, this is a cation of weak base. So this is a salt of weak base plus weak acid. So this means both will hydrolyze. So this will also hydrolyze the water, this will also hydrolyze the water. If one that hydrolyzes more will basically guide the pH of solution. Let us say how we will proceed this one. So this kind of problem we have already said, we can write NH4 plus HCOO minus plus H2O, and I will write the reaction. So first let us write two hydrolysis equilibria. So let me remain this as it is. So if I consider separately, NH4 plus will hydrolyze the water H2O, and it will form NH4OH plus H plus. Are you getting? Now what will be the equilibrium constant for this reaction? That is, the hydrolysis constant for this reaction will be Kw by Kb, because this behaves like acid. So I have to take reverse of Kw by Kb, that is equals to K. So this is behaving like acid. Another is HCO minus, this will also hydrolyze the water. So equilibrium constant for this reaction you will have HCOOH plus OH minus, this is behaving like base. So equilibrium constant for this reaction you will have Kw by Ka. Now I have to add basically these two equations. I have to eliminate H plus and OH minus. So what I will do? So let us say H plus plus OH minus. This goes H2O. This is the reverse of 1 by Kw. So equilibrium constant for this reaction is 1 by Kw. Now if I add these three reactions, and basically in class we have discussed why we can add these three reactions. So if I add these three reactions, I have H plus OH minus, that is gone, and H2O, that is also gone. So I will have NH4 plus HCOO minus plus H2O, and this will give NH4OH plus HCOOH. Now equilibrium constant for this equation will be multiplied. So Kw by Kw. So the top we will have Kw divided by Ka into Kb. So equilibrium constant for this reaction will be Kw by Ka into Kb. Are you getting? Now things are simple. We'll consider this reaction and we will try to solve. So copy. So using this equation we will try to solve. So NH4 plus, we have this equilibrium constant, HCOO minus plus H2O, and this gives me NH4OH plus HCOOH. Let us copy this one, and I know the equilibrium constant for this reaction Kw by Ka into Kb, that is the equilibrium constant for this reaction we have derived on the top. Now initial concentration of this is 0.1 m or 1 m, so this is given in question. This is 1, this is also 1. Now let us say this minus x, this also minus x, we have x here, x here. So now I can write x square divided by 1 minus x whole square. This is equals to Kw by K into Kb. Are you getting or not? Now I can solve for x by 1 minus x. X by 1 minus x is nothing but root over Kw by K into Kb. Now any one of the equation I can find, using any one of the equation we can find the value of. So let us calculate Kw by x by 1 minus x. What this comes out to be? So under root Kw is 10 to the power mod minus 14, and K is not given in the problem. Okay, so Pk is given, so I have to find Ka, and then I have to find Kb using the Pk and Pkb. That will be slightly difficult task, so leave as it is. So let us don't solve this equation, otherwise we will have so many calculations. So let us leave this as it is. Now let us make an assumption. So what assumption I can make? Assumption I can make that is x is much less than 1, and further I will check whether this assumption is right or wrong. So let us make assumption that is 1 minus x is approximately equals to 1. So I can write x is equals to under root Kw by Kb. You see, if I have known the value of Kb, I would have basically said whether should I approximate or not. So x is Kw by Kb. Now x is what? X is the concentration of either HCOOH or concentration of NH4OH. So this is the concentration of either NH4OH or this is the concentration of HCOOH. Both are equal. So this is also x, this is also equals to Kw by Kb. Are you getting? So now let us use these equations to find concentration of H plus. So let us say this equation. I can use this equilibrium NH4 plus H2O because I know the concentration of NH4 plus. This remains approximately equals to 1 minus m. So we have said this is 1 minus x. This is approximately 1. I know the concentration of this. I can find calculation of concentration of H plus. So let us use this equation NH4 plus H2O. This will give me NH4OH plus H plus. And equilibrium constant for this reaction is Kw by Kb. Now concentration of NH4OH is x. This is basically 1 minus x. And concentration of H plus I can find using this equation. So I can say concentration of H plus into x divided by 1 minus x. This is equals to Kw by Kb. And I have already assumed that 1 minus x is equals to 1. So H plus is nothing but Kw by Kb by x, and the value of x I know, so this is Kw by Kb, and x is, you see here you have x is Kw by under root Kb, so you will have here under root Kw under root Kb. Are you getting? So copy this one. So now if I plug these values, I will have h plus this is equals to, so let me say, so I will have h plus this is equals to kw goes out, so we will have under root kw on the top. This kb goes, so we will have kb under root in the denominator. We will have k in the numerator. So if you take log both sides, so we will have log h plus this is equals to 1 by 2 log kw plus log ka minus log kb. Now if you take minus both sides, if you add a minus sign both sides, so let us multiply by minus, so minus log h plus this is equals to half minus log kw minus log ka minus of minus log kb. So basically I have multiplied by minus sign. So minus of log h plus is nothing but ph. This is equals to half of log of kw is nothing but pkw. Log of k minus log of k is nothing but plus pka. Log of kb, that is pkb, so this is minus pkb. Now things are very easy. I know the value of pkw, that is 14, and pk is given in the problem, you see. So pk is, let me see, so pk is 3.8 minus pkv is also given to you, that is 4.8. So I can solve for pH. Are you getting? Everybody getting up to this point or not? So let me see this calculation I can do. I think you have copied this one. So let us do this calculation. So this is 14 plus 3.8. So we will have 14 plus 3.8. I think you are able to see this one. Minus 4.8. This is equals to 13 and divided by 2. So we will have 6.5. So the final pH is coming out to be 6.5. That is slightly acidic. So let me, I think I can remove this one. So final pH is 6.5. So pH that is coming out, that is basically 6.5. Are you getting? So this is solution is slightly acidic. If you want, basically we can check one assumption. We have one assumption. Assumption is 1 minus x is approximately equals to 1. Let us try to verify. So let us find the value of x. How can we find the value of x? So x is, so basically to find x, I have to use this expression. So see this equation, basically this equation I have done this one, x by 1 minus x, this is equals to under root kb by k. So I have to use this equation. So x by 1 minus x, this is equals to under root kw by ka into kb. Now I can solve this equation only if I know ka and kb. So pk is given, pka is 3.8. So what is the value of ka? I can solve. So pk is 3.8. So what is the value of ka? So I can find this value using the calculator. So let me use my calculator. So this is k is 10 to the power minus 3.8. So I will have 10 raised to the power minus 3.8. You getting or not? So this is pk is 3.8. So 10 to the power 3.8 minus 3.8. So what is the value coming out to be? So this is coming out to be 1.58 into 10 to the power minus 4. You can see clearly. I think you are able to see this 10 to the power minus 4. I think you are able to see. Not able to see. So this is 10 to the power minus 4. I think if I keep it here. Okay, let us see. This is 1.58 into 10 to the power minus 4. 10 to the power minus 4 is not visible to you. 1.58 into 10 to the power minus 4. Similarly, I have PKB is given to you. PKB is 4.8. I can find KB. KB is again 10 to the power minus 4.8. So this is 10 raised to the power minus 4.8. Are you getting? I have to see this value. So this is coming out to be once again 1.58 into 10 to the power minus 5. So this is 1.58 into 10 to the power minus 5. If I plug this value, I can solve for x. So this is x by 1 minus x. This is equals to kW is 10 to the power minus 14. K is 1.58 into 10 to the power minus 4. And this is also 1.58 into 10 to the power minus 5. So if you solve, this will come out to be. So let me solve this one. So you just copy this thing. And let me solve. So this is 1.10 to the power 1.58 into 10 to the power. So this is, I can solve this. 10 to the power minus 7 on the top. This is 1.58 root over 10 to the power minus 9. So this value I can solve minus 9 only. Are you getting? So this is 10 to the power minus 9 because 1 point, so we will have let me solve 10 to the power minus 7 divided by 1.58 and this divided by root over 10 to the power minus 9. 10 raised to the power minus 9. So we will have this value. So this is coming 2.2 into 10 to the power minus 3. So this value is coming out to be 2 into 10 to the power minus 3. So this value is very small. So even if I neglect this one, so if I simply write x, 1 minus x, if I neglect this is equals to x, so x is coming out to be 0.002. So what is the percentage error? I am writing 1 minus x as x. So I am basically doing this into 100. So I am doing only 0.2% error. Are you getting or not? So basically my assumption is valid. I can always write x 1 minus x is equals to x. So this problem is basically a good problem. You have to remember this result. If you remember this result, all calculation we don't have to do. So this result, if you have a solution of weak acid plus weak base, pH is given by this expression. You can leave all this calculation if you remember this result. There is no point of doing all this calculation. If this is a question asked in exam, in that case you don't have to do all this calculation. You have to simply remember pH will be half pKw plus pKa minus pKb. This result is slightly useful to remember. One thing is you have pH, that is the pKb will be minus, other will be simply plus. Are you getting? So you see why we have a minus. If the pKb is higher, then solution will be more acidic. Are you getting or not? So if the pKb is higher, this means hydrolysis constant is lower. If the hydrolysis constant is again higher, you can think yourself, hydrolysis constant is higher, in that case the H plus will come more due to the base, hydrolysis of base. So this is all about this problem. So you have to remember this result and we will discuss the next problem. This is an easy problem. This covers the concept of salt of a strong weak acid weak base, hydrolysis of a salt that is having a strong weak acid weak base. Okay, let us copy this one and then we'll go for the next problem. I think all of you have copied this one. Easy problem.